In this video, I'm going to be going through quite a number of questions. So it is going to be a bit of a longer video than normal, but I wanted to go through all the different types of questions about right angle triangles that you might get. So our first two here, you can see that we have two sides given to us and a third side that we want to get. Now this is our clue that it is going to be Pythagoras theorem rather than using our trig ratios. For our trig ratios, we need to have an angle. So if you see, look at this third one here, see how an angle is given to us there? That's our indication we're going to use our trig ratios. So up here, no angles, so it's Pythagoras theorem. So firstly, I always start by labeling my triangle. Now, in this case, we've been given the C. That's our hypotenuse. And then we can choose to put the A or the B on 3 or 4. It doesn't matter which we choose in Pythagoras theorem for A and B. It's only the C that matters. So when we choose those, I'm going to choose an A here and a B here. So I'm then going to write my rule. So I'll write my C squared equals A squared plus B squared. Now I do have some students who like to write it as A squared plus B squared equals C squared. That's totally fine as well. So now we're going to put in what we know. C squared is equal to, and we've got 3 squared plus 4 squared. So our next step is to work them out. 3 squared is 9, 4 squared is 16. When we add them together, we're going to get 25. So to get our C value, we're going to have to do the square root of 25, which is 5. This one you can see falls into our golden ratio triangle, 3, 4, 5. The next one, you'll notice we don't have our C on the hypotenuse. Instead, we've got an unknown here on a side. So I'm going to go through the same process. So starting by labeling again. So I'll put my C. I've already got a B, so I'm going to put my A there. I'm going to write my rule. C squared equals A squared plus B squared. Then I'm going to fill in the values that I know. So I know that C squared is 9 squared. So I'm going to write 9 squared. Then I'm going to write 5 squared plus B squared. Now I know that 9 squared is 81, 5 squared is 25, and then I write my B squared here. Now to get my B squared on its own, it's got the 25 added to it. So the opposite of that is taking away. So I'm going to do 81 take 25, and that's going to give me the B squared. So I'll do that on my calculator, 81 take 25, and I get 56. Then to get my B, I need to do the square root of 56. Now when I do the square root of 56, put my calculator here, I can do second x squared. That gets my square root sign on the calculator. Now what I can also do is use my previous answer, so that's why my 56 is up there on the screen. I can just use that, bring it down, and it will do that answer for me. Now you might notice this on your calculator, 2 root 14. We want to get the decimal value of that. So we're just going to press that arrow button here to change it to a decimal, and we get 7.4833. Now we could round that to 2 decimal places, so we'd write 7.48 is equal to B. If you wanted, you could do the wavy lines to show that's approximating. So when you're finding the hypotenuse, you're doing your adding up here. When you're finding one of the other sides, we are doing the subtraction. Now remember, our hypotenuse is always the one opposite the right angle. It doesn't touch the right angle, and it's always the longest side on the triangle. Now we get to our next set. So now we have some angles. This means we're going to be using some of our trig ratios. Now you might have seen the SOHCAHTOA to help you remember. So always, again, labeling the triangle first. In this types, instead of doing ABC, we're doing our A, O, and H, our adjacent, our opposite, and our hypotenuse. So in this case, I can put my hypotenuse on that side that's opposite the right angle. Then I need to put my adjacent, the one that's closest to the angle. So here's the angle here. So that one's going to be the adjacent. And then the one opposite the angle is going to be my O. Now, then my next stage is I like to circle where I have a letter and a number or 2 letters. So that means I've got O and A. And when I look at my SOHCAHTOA reminder here, that tells me I'm going to use tan. So I'm going to write my rule here, tan theta equals opposite over adjacent. Now I'm going to put in what I know, tan of 50, because theta is just my angle, is equal to x over 3. Now don't forget to make sure your calculator is in degrees. When you look at the screen here, you'll see there's a little DEG. If it has something different there, do a reset and it should bring it back to degrees for you. Or you can go into the mode and choose degrees. So now that we've got tan 50 is x over 3, we're going to multiply by 3 because that means x divided by 3. So 3 tan 50 is going to give us x. So we can type that straight into our calculator. 3 times tan of 50, and we get 3.575. And our unit here is meters, so we can put the meters there. In the next one, starting the same process again, labeling our triangle. So I've got my adjacent, the one that's right near the 70 degrees, my hypotenuse is over here, and my opposite is the one that is opposite the angle. So now I'm going to circle, and I can see I've got an O and a H. So that means, looking at my one up here, SOH is going to be sine. So I'm going to write sine theta equals opposite over hypotenuse. Then I can put in my values. So I can write sine of 70 is equal to x over 10. And just like the one up the top here, the 3 was on the bottom, so we multiplied by 3. The 10 is in the bottom, we're going to multiply by 10. So 10 sine 70 is going to equal x. I'll grab my calculator and do 10 times sine of 70, and I get 9.396, so I might round that to 9.4. And that is going to be meters. Now I'm going to go on to my next page. So my next one that I've got up the top here, I'm going to label my triangle. So I've got my hypotenuse, I've got my adjacent, and I have my opposite. Then I can circle and see that I have A and H. So I'm going to write cos theta is equal to adjacent over hypotenuse. So then I can put in what I know, cos 40 equals x over 11. And again, we've got our 11 on the bottom, so we're going to multiply. 11 cos 40 equals x. Grab my calculator. And I get 8.426, so I'll round that to 8.43. And that is going to be centimetres. Now, I've tried to give you an example of every type that you will come across. So I've done where our unknown was on the top of the fraction for tan, sine and cos. And now I'm going to look at the next set where our unknown is going to be on the bottom. So labelling my triangle, always our first step. So I've got A, O, H. And then I circle. So I've got AH, just like I had here. Cos theta equals A over H. So then I'm going to put in what I know, cos 30 is equal to 7 over x. Now this is where I've got an x on the bottom. Now I like to teach my students that they can just make it swap sides. But if you're not sure why that works, when we've got an x on the bottom, we want to multiply both sides by x. So we would end up with x cos 30 equals 7. And then to get the x on its own, we would divide by cos 30. I like to say the quick way is just if an x is on the bottom, make them swap sides. So I get 7 over cos 30. So I grab my calculator, 7 divided by cos 30. And again, it's come up with that 14 root 3 there. So I'll just press my arrow and I get 8.082. So I'll round that to 8.08. And my units are centimetres. Now our next one that we've got here, we've got our 60 degrees there, we've got our hypotenuse there, that means our adjacent is here and our opposite is over there. circling. So this time I've got O and H, so it's going to be sine. So I will write sine theta equals opposite over hypotenuse. Sine of 60 is equal to 12 over x. So you can see I've set it up again the same with our x on the bottom. So I'm going to make them swap sides. X is equal to 12 over sine 60. And I'm just going to write this to the side here. I normally wouldn't. I'd always go down the page, but I'm running out a little bit of space there. So I'm going to do my 12 divided by sine 60. And I get 8 root 3, which I will then press my across arrow, and I get 13.856. So I'll round that to 13.86. And that will be centimetres. Then our next one, we've got our labelling first. So we've got our hypotenuse, we've got our adjacent, we've got our opposite. So I'm going to circle what I know. I've got O and A, so it's going to be tan. So I'm going to write tan theta equals opposite over adjacent. So I've got tan of 40 is equal to 7 over x. And like I said, another example where the x was on the bottom, we make that switch sides. X is equal to 7 on tan 40. And again, in terms of keeping enough space for the next one, I'm just going to write that beside there. So I've got 7 divided by tan of 40. And I get 8.3422, so I'll round that to 8.34. And the units are metres. Now, the next time, this is where we don't know the angle. So we've got that theta there, we don't know that. So we're going to use the same process, and I'm going to show you what to do in that last step. So first, like every other question, labelling our triangle, H, A, O. And then that means when I circle, I've got O and A. So I've got tan theta equals opposite over adjacent. So that means I have tan theta is equal to 6 over 3. So then to get the theta, I've got to do the opposite of tan, or the inverse of tan. And the little symbol we use is tan to the negative 1 of 6 on 3. So when I do that on my calculator, I'm using this second button here. So I'm going second tan, and see how that comes up on the screen to the power of negative 1. And then I can put that fraction in there. And 6 divided by 2. And then get enter. And see how I get this number on my screen, 71.565. So I'd round that to 71.57. That answer is going to be degrees, because we've found our angle. So always remember that your angles are measured in degrees. That's one thing I do notice. I get some errors with students where they think their angle is going to be measured in meters, or they might say their side length is in degrees. So always remember, angles measured in degrees, your side lengths are in either centimeters, meters, kilometers, millimeters, etc. Now, another 2 solving angle type ones. So labeling to start with, our H, A, O. So in this case, we've got something with O, something with H. So that means we're going to have sine theta is equal to opposite of hypotenuse. So then I've got sine of theta is equal to 5 over 8. So then to get the theta on its own, I'm going to do my sine to the negative 1. And this works just like the tan. And in that bracket, I'm going to have 5 over 8. So I'll grab my calculator. I'll do second sine. See how that comes up with the negative 1 there. And then I've got my 5 over 8, which is what I had in my bracket there. And press enter. And I got 38.68 degrees. And my lucky last one, finishing off with another angle one, I have my labeling, H, O, A, circling. I've got my A and my H, which means I'm going to have cos theta equals A over H. Then I'm going to put in what I know. Cos of theta is equal to 10 on 17. So then theta is going to be cos to the negative 1, 10 on 17. I grab my calculator. I've got cos to the negative 1, 10 over 17. and I get 53.968. So I'll round that to 53.97. Okay, so slightly longer the video than normal, but hopefully that was helpful to see all of those types of questions together.